Yo, what's up, crew? Welcome back to SAT Hijackers, the channel where we hijack the SAT one problem at a time. Today, we're diving into the geometry questions from Practice Test 4. But this isn't just about getting them right, it's about getting them done fast. Let's be real, SAT doesn't care how smart you are if you can't beat the clock. You've got under 90 seconds per question. In geometry, that's where most people slow down. Second guess and lose points they shouldn't. So here's the mission. I'll break down each question the way you should attack it on test day. Clear steps, smart shortcuts, and no wasted time. Let's go. So here we have a right triangle problem. A right triangle has sides of 2 root 2, 6 root 2, and root any units. What is the area of the triangle in square units? So here, I'm going to draw a right triangle to help you guys visualize this problem. So a right triangle. Always remember to have your right angle in the corner. So here I'm going to show you guys the main trick of this problem. So we have lengths of 2 root 2, 6 root 2, and root 80. So the main trick of this problem, guys, is the fact that you have to be able to categorize these numbers from greatest to least. So you have root 80 is the greatest. Root 80 is greater than 6 root 2, and 6 root 2 is greater than 2 root 2. Because we have a right triangle, we know that our hypotenuse has to be the greatest side. So that means root 80 is the greatest. So that means our hypotenuse has to be root 80. So we have root 80 as our hypotenuse. And because we have that, we can have 6 root 2 as our leg and 2 root 2 as our other leg. This is the main trick in this problem. If you aren't able to categorize each side length to each side, you'll be able to put the wrong base and height for when you go to calculate area. We're going to have 6 root 2 as our leg. So now, the formula for area is area equals 1/2 base times height. So now area equals 1/2 base times height is how we're going to solve this equation now that we have both our legs, which are the base and the height. So area is going to equal 1/2. Area is going to equal 1/2 2 root 2 times 6 root 2. So now that we have everything, now we just need to multiply. So 2 times 6, then we're going to have to do root 2 times root 2, which is the same as root 2 squared. So now we're going to have area is equal to 1/2. So area is equal to 1/2 12 times 2. So our area is equal to 1/2 12 times 2, and we're multiplying by 1/2, and then we're multiplying by 2, so we can cancel those out. So now we get area is equal to 12, and since area is equal to 12, our answer is B. Pretty easy question, guys. You gotta understand the trick, where you're supposed to categorize the leg. Okay, now so we have a pretty simple right triangle problem here, guys. Right triangle PQR and STU are similar, where P corresponds to S. If the measure of angle Q is 18 degrees, what is the measure of angle S? So we already have our right triangles drawn for you, and the problem says right triangles PQR and STU are similar. So that means all corresponding angles on this triangle are congruent. So I'm going to draw my congruency symbols on my angles. So P corresponds to S, and Q corresponds to T, and R and U are both right angles. So I'm drawing my corresponding angles. Give me a second, guys. So now we show that our angles are congruent. We know that angle Q is 18 degrees, so I'm going to write angle Q is equal to 18. I'm going to have that written. We know that angle T is congruent to 18 degrees because both triangles are similar. Now that we have that, now we know that angle R is equal to 90 degrees. So I'm going to write my 90 degrees. R equals 90 degrees. So that means angle U is also 90 degrees as well, as both triangles are similar. So now we create our equation. 180 degrees is equal to 18 plus 90 plus x. And our x is the same as the missing angle S. So 180 degrees is equal to 108 plus x. And after that is a pretty simple two-step equation. We subtract minus 108 from both sides. Subtract minus 108 from both sides. So 180 minus 108. So x equals 72 degrees, which makes our answer B. It's a pretty simple equation. Shouldn't take anything hard. It's just understanding the trick and the concept behind corresponding and similar triangles, which means that their angles are congruent to each other. Their corresponding angles are congruent to each other, guys. So here I have a pretty simple rectangular problem. It says, for a certain rectangular region, the ratio of its length to its width is 35 to 10. If the width of the rectangular region increases by 7 units, how must the length change to maintain this ratio? Okay, this is a pretty simple problem about geometry and ratios. So I'm going to draw a rectangle to help you guys visualize this problem. So I'm going to draw this rectangle real quickly. So and then we're going to draw a length and width on a rectangle. So we're going to have 35 as our length. And we're going to have 10 as our width. So now I'm going to draw this length and width as a ratio. So we're going to have 35 to 10. 35 to 10, which can be drawn as a fraction as their equivalent. So we're going to have 35 over 10. And we're going to write this fraction as a whole number, which is also equivalent. So we're going to have 3.5. 3.5. Okay, so now I'm going to help you guys visualize the ratio change in this problem. So we can write it as this: for every one singular increase in width, there's a 3.5 increase in length. So the ratio to width to length is 1 to 3.5. So for one width, it is a 3.5 increase in length. So now we can say if we have 7 widths, a width of 7, we have to multiply this number by 3.5 to get what the length would be to maintain this ratio. So times 3.5 to the 7 width. So we're going to have 7 times 3.5 is equal to 7 times 3.5 is equal to 24.5. 24.5. 24.5. And because it says the width of the rectangular region increases by 7 units, we know our answer must be B because it talks about increase as well. So our answer is B. Pretty simple problem if you know the ratios. So here we have a square problem. So now square P has a side length of x inches. Square Q has a perimeter that is 176 inches greater than the perimeter of square P. The function f gives the area of square Q in square inches. Which of the following defines f? Okay, so this is a pretty simple square problem. So now I have 2 squares drawn up in the corner that I'm going to represent as P and Q. I'm going to have x to represent the side lengths of P. So I'm going to draw 4 x's around the boxes. There are 4 sides on a square. Then I'm going to have y on my Q square to represent the sides of square Q. Okay, I have 4 y's. Okay, so now I'm going to draw a perimeter of square Q is equal to 4x plus 176. I have 4x as At 4x as the perimeter of square p is equal to 4 plus is equal to all its sides added up to each other. So the square has all equal sides. It's 4 times the same number. So now we have 4y is equal to 4x plus 176 as the perimeter of square q is equal to all its sides added up to each other, and because they all are the same number, it's 4 times itself. So square q is equal to 4y. So we're it's a simple two-step equation from here. Now I'm going to divide by 4 on both sides. I'm going to have y is equal to x plus 44. So now we're not done here yet. It didn't ask for the side. It asked for the area. So I'm going to draw the area of a square, which is a is equal to side squared. So now a is going to equal to y squared as each side is equal to y. And now it says I want to define the area as function f of x. So I'm going to put area is equal to f of x. So now I'm going to write f, which is the same thing as the area. So f of x is equal to f is equal to x plus 44 squared as y is equal to x plus 44, and since we're squaring it, we put x plus 44 squared, which makes our answer A. Pretty simple problem. You just have to understand the concept of perimeter and how to apply it in a two-step equation. Okay, so here we have a circle problem. Point O is the center of a circle. The measure of arc RS on the circle is 100 degrees. What is the measure in degrees of its associated angle ROS? So as you guys can see, I already have my circle over here drawn with ROS, and I'm going to label my circle with 100 degrees as for arc angle ROS. And now I'm going to draw my associated angle ROS in the center, and I'm going to write the missing angle as X. So if this problem is very easy if you know this one single concept. I'm going to write it out for you guys. Arc RS is congruent to associated angle ROS. Therefore, 100 degrees is equal to associated angle ROS, which is the same as saying 100 degrees is equal to X. So our answer is 100 degrees. Pretty simple circle question, guys.